What's up? This is Pang from LabVIEW by Example. Thank you for joining me today. In this video, I'm going to show you how LabVIEW's case structure works when you wire a number into its selector. So in my last video, I showed you how a case structure operates when a string is wired into its case selector. So I went through a small example in C#, and if you need a quick refresher on that concept, the switch case concept, spend a little time watching that one and shoot back over here when you are done. Okay, let's see now what happens when the number, or as LabVIEW refers to them, numerics, are wired to the case structure. So let me bring up a block diagram of a VI. Say new VI. And I'm going to click on an empty space in the block diagram to bring up the functions palette. Left click on case structure. Okay, and then left drag and draw your case structure. And this kind of looks like you're drawing instead of programming. So I always feel like that sometimes when I'm doing LabVIEW programming. So when I create a numeric constant, so let's go ahead and do that. And wire that to the case selector. LabVIEW will detect that data type, and instead of going from true and false, it's going to go from 0 to 1 and make this case selector blue. Okay, so it's detecting an integer, which are whole numbers like 1, 2, 0, -10, etc. So the default values that LabVIEW puts in the selector are 0 and 1. Just to start out, the default is set to 0, so which means that if no numbers match, so for example, if this was a 5, it'll automatically go to this 0 case, even though it's not 0, but it's set to default. So we'll change that in a sec. Okay, so in this example, let's make a function that prints out a number. Prints out the number as a spelled out word. So let's do that for -1, 0, and 1. So what I'm going to do is create a string indicator on the front panel. So I'm going to do a Control E to get the front panel, and let's go ahead and tile these two up so that we can have things side by side. Okay. And let's go ahead and create a string indicator here. Okay. So what I'm going to do is put that outside of the case structure to the immediate right. Oops. As so. Okay. So for the 0 case, I'm going to create a string. So what I can do is just create a string constant and type 0. Wire that out of the case structure. And as you can see, there's a tunnel created, and it's going to be hollow, which means that it's white inside. So that's how I kind of visualize it. So let's move on to the 1 case, and let's create a constant. So what you can do is hit right click on the tunnel, hit constant, and type in 1 for that. Okay, for -1, I want that before the 0. So let's go ahead and right click on the label and say add case before. Okay, -1. And then I right click on the here, create a constant, and type -1. To catch all of the numbers, I want to create a default case. So let's create a case afterwards. And this time I'm going to make that blank and then make this the default case. So now we have -1, 0, 1, and then default for any other cases. So for this guy, I'm going to use an empty string to the screen, but I'm going to show a dialog. There you go, dialog, telling the user that I couldn't recognize. Okay. Move things around a little bit. Okay, so let's go ahead and try this out with 0. I have the string 0, 1, 1. Let's try -1. Okay, and then let's try 2. Yep. So it says, oops, that number wasn't recognized, and it has an empty string. Okay, so for numbers, in my last video, I talked about how strings can, you can use a string into the selector and have multiple strings in each case. So you can do the same thing with integers as well. So say in this case, I want to key off 1, 2. So I put 1 in there and put comma 2. Okay. And let's say here 1 or 2. Okay, if I run this now 2, well, I'll put 1 or 2. Okay. So now let's say that I want to print out a string based on a range of numbers rather than a specific number. Let's change things up so that the function will output the word low for numbers between 0 and 3, medium for 4 to 7, and high for anything above or 8 or above. So I'm all about shortcuts. So let's go ahead and edit our current cases. So going to the -1 case, I'm going to type in 0. So for now, so to specify a range, you type 2 dots, and then the upper end of the range, which is going to be 3 in our example here. So I want to make this low. Okay, for medium, I want to go from 4 dot dot 7. Okay, and then for high, I want that to go from 8, and then I don't want to do anything 8 or above. So what I do is just hit dot twice and leave that open. So this is going to be high. So let's go ahead and try this. So this is at 2 right now, so this should be low. Okay, let's try 4. This should be medium, and let's try 100. That should be high. There you go. So this works the other way around too. So I can actually change this guy and take out the 0. So I can just go dot dot 3. And if I put -99, for example, I have low. Okay. So what happens if the ranges overlap? So let's edit the 0 to 3. Well, actually, dot dot 3 with a comma 5. Okay. So notice that it's not complaining about the case structure itself. So you can mix and match discrete numbers with ranges, but I do get a broken arrow, and if you hit that guy, it says that the ranges are overlapping. A selector value is used by more than one case. So you can hit show error, and it shows you that um, is where the problem is. So now you've got an idea about how case structures work with integers. So let's take a look at how they behave within enum. Okay. So enumerated types or enums are special objects in a lot of programming languages where you put string labels that correspond to integer values. These are useful because they provide meaning to all those numbers that you'll definitely have scattered in your code. So let's take a look at my last C# example with switch statements. So last time I used strings in the switch statement for each case label. So one glaring problem with this was that these cases would not um, execute if any of these strings were misspelled or even capitalized exactly how I had it here. So one solution is to change the case to check for numbers. So for example, I could put this as 0, 1, 2. Okay, and I would have to change this data type, of course. But so what's the problem with this? So the problem is no one reading your code will know what these numbers mean. So that includes you looking at this code, looking at your code months in the future, trying to figure out what these quote unquote magic numbers mean. So let's use enums instead to make the world a little more happier. So I'm going to use the enum keyword to create the list of states. So I'm going to put that right before this class. States, go, stop, slow, go. Okay. And I'm going to change this guy from that to that. Go. And we're going to change the selector for that switch statement to our new variable. So this is going to be state.stop, state.slow, and state.slow, state.go. Okay. Save and run. So right now it's set to go. Go is green. And let's make sure that stop works. Okay. So everything works the same as before, but with more maintainable, readable, and self-documenting code. So now let's get back to LabVIEW and see how we can create enums. I'm going to create a new VI. Okay. So I'm going to create an enum constant by finding it on the functions palette. So if I do a Control E, functions palette, and let's find the enum constant here. Okay. So to create a list in this enum, I'm going to hit the right click and say edit items. Okay. It gives you up a properties window where you can add whatever items you want for your enumeration. So in this example, let's use the names of cup sizes at Starbucks. So we've got, so if I hit double click that, I have short. All I have to do is hit enter, the enter key, tall, grande, and venti. So as you can see, the underlying enum values are on this column here. So they increment from 0, 1, 2, and 3. Hit OK. And as you can see, all my new values are in this enum. So now let's create a quick case structure and wire that enum to the case selector. So let's go ahead and do that. this down here and wire. So when I do that, notice how the first two items show up automatically. So I have tall, short, and tall already there. So if I want to add another, so let's right click and say add case after. The LabVIEW automatically detects this enum and puts that label in there. That's pretty neat. So another nice feature is the ability to create all the cases at once. So let's see this in action. So if I delete whatever I created just now, so let's delete this case, and just leave the first one there. So I don't know what happens if you delete all cases. What you can do is say right click and add case for every value. So now you have all your cases. So that's super convenient. So what if I try to add a case that's not in this enum? So if I go here and let's go ahead and add case after, and let me type gigantic. So you can see pretty obvious that's not part of this enum because this is in big, well, red text, and you have a broken arrow as well. And again, clicking on that gets you to the problem. So enums are really nice to have. It self-documents your code, and case structures in LabVIEW just responds to these values that you place in. So you can go ahead and change, add whatever you need to the code. I was going to show you how to do something like show the size of the cups in ounces on the GUI, but I'm pretty sure you guys can figure that out on your own. All right, cool. Congrats. You are now able to create VIs with case structures using a numeric or enum as a selector. So I would recommend that you go ahead and try things for yourself. See what else you can do with case structures, and feel free to let me know if you need any more videos on this topic. So go ahead, add your comments and likes below, or just go to labviewbyexample.com and let's discuss. Thank you for watching. Later, guys.